the short notes from section 1.2, which is on finding limits graphically and numerically. We're really going to focus on how to find the limit graphically. Example 1 is kind of an introduction to what a limit is. It gives us f of x equals x squared plus 2x minus 35 over x squared minus 25. And what it wants to know is what does the graph look like, or what is happening at x equals 5. So what's going on with this graph at x equals 5? I put x equals question mark. At x equals 5. So the very first thing you would do is you try to figure out what the y value is at x equals 5. So let's plug in 5 for x and see what happens. So that's going to give me 25 plus 10 minus 35 on the top. And on the bottom, if I plug in 5, I get 25 minus 25. So on the top, I've got 0, and on the bottom, I've got 0. I've got 0 divided by 0. So if I divide by 0, this is undefined. So f of 5 is undefined. There is no point when x is 5. So if there's no point, I guess the next thing you would want to look at is not what's happening at x equals 5, but what's happening as I get close to 5. So I'm going to plug in some values here. I'm going to plug in 4.9 and 4.99. 5 we know is undefined. And then a couple on the other side of 5, 5.01 and 5.1. And I'm going to use my calculator here real quick to get those y values. So if I put in 4.9 for x, and I plug it into the function, I get 1.202. And if I plug in 4.99, I get 1.2002. 5 is undefined. If I plug in 5.01, I get 1.1998. And plugging in 5.1 gives me 1.198, I think. Yeah, 1.198. So when we're looking at what's happening at 5, first of all, we have no value. There is no point. The f of 5 is undefined. But then the second question is what's happening close to 5. So what is happening at x equals 5? F of 5 is undefined. But then a secondary question would be what is happening close to 5? And close to 5, the y values are getting close to they're getting closer and closer to 1.2 on both sides here. That was 1.198, 1.998. The next one would be 1.19998. The y value is getting close to 1.2. So what this is it's a limit. We define this as a limit. The notation we use is that LIM as x approaches 5 of f of x. So this is telling us we're evaluating a limit, what the x value is getting close to of the function equals, and in this case, the y value was 1.2. So there's lots of different ways that a graph could have a limit. And the first is if it just passes through that point. A limit is what's happening close to the x value. So as I get close to this value on this side and this side, I'm getting close to some y value over here. So this limit exists. This one would also exist. I'm getting closer and closer to some y value. So even though the function is undefined, I have a hole there. As I come in from the right side and I come in from the left side, there's one y value that I'm getting close to. Even if the function value is defined somewhere else. I think maybe more interesting would be to look at some graphs that have limits that do not exist. One like this. As I come in from the left side, I'm coming up to one y value. As I come in from the right, I'm going to a different y value. Because those are two different y values, this is called a jump. And the limit does not exist in that case. It also would not exist if we have a vertical asymptote. The limit as x approaches 3 in this case, because we have that vertical asymptote, does not exist. Those are the two big ones that you need to know right now. So most of the problems in this section will look something similar to this, where they give us a graph, and then they ask for different things. They ask for f of -3, the limit as x approaches -3 of f of x, and so on. Let me step back just a minute here. If it ever wants to know what is f of something, so like f of 7, this is answering the question, what is y when x is 7? F of 7 wants to know the y value. What is y when x is 7? If it says the limit as x approaches 7 of f of x, we don't care what's happening at 7. What we want to know is what's happening infinitely close to 7. What's happening at 6.99999 and 7.00001. So this wants to know what is y approaching as x approaches 7. So going back to our example here, when it asks f of -3, it wants to know when x is -3, what is my y value? When x is -3, my y value is defined to be this point right here. The y value is -2. The limit as x approaches -3 of f of x, I no longer care what's happening at -3. I want to know as I get close to -3. So as I'm coming into -3 on the left side, and as I'm coming into -3 on the right side, what is that y value getting close to? And that y value on both the left and the right is also coming into -2. It is possible that the function value and the limit are the same thing. And that happens at most points. Most points on the graph, the limit and the function are the same. Part C, f of -5. F of -5 wants to know when x is -5, what is y? When x is -5, the y value, that's a hole, is defined to be this point right here. The y value of that point is -3. The limit as x approaches -5 of f of x, as I get close to -5 on both sides, as I get close to -5 on the left, as I get close to -5 on the right, the y value on both sides is getting close to not this -3 down here, it's getting closer and closer to 2. F of -1, when x is -1, That's a hole. There is no y value. There is no point on my graph that has an x value of -1. We say f of -1 is undefined. The limit as x approaches -1 of f of x, as I get close to an x value of -1, I'm getting closer and closer to this y value right here, which is -1, 2, 3, 4, 5. F of 1, when x is 1, my y value is 2. As I get close to 1, as I come in from the right side, I'm getting closer and closer to 2. As I come in on the left, though, I'm coming into a different y value. Those are not the same y value on both sides. That is a jump. Therefore, the limit does not exist. Generally, we say function values, if they're not there, are undefined. Limits, if they're not there, do not exist. If you get those mixed up, that's not an issue. F of 4. 4 is right here. I have a vertical asymptote at 4. F of 4, therefore, is undefined. And the limit at a vertical asymptote does not exist. Part K, f of 6. 6 is this x value right here. The y value is -2. And the limit as x approaches 6 of f of x. As I come into 6 on both sides, my y value is getting closer and closer to -2. One more problem like this, if you're viewing this at home for the first time, it might be a good idea to pause the video and try this one on your own. And then once you think you've got it, I will show you how to do it. So part A is asking for the limit as x approaches -1 of g of x. So as I approach -1, so -1's right here. As I get close to -1 on both sides, my y value is getting closer and closer to 3. Part B, the limit as x approaches -5. 1, 2, 3, 4, -5's right here. As I come into the left and the right, those are two different y values. Therefore, the limit as x approaches -5 of g of x does not exist. G of -5, when x is -5, the y value is 1, 2, 3, 4, 5. G of 5, what is y when x is 5? There's not a y value. The limit as x approaches 2 of g of x. As I get close to 2 on both sides, my y value is getting close to 1, 2, 3, 4, 5. G of -1, when x is -1, my y value is 3. G of 2, when x is 2, my y value is -1. And the limit as x approaches 5 of g of x, I have a vertical asymptote at 5, limit does not exist. That is it for the notes in section 1.2. If you're having questions on anything, please reach out, let me know.